Hi, everybody. I'm just going to jump right in here. So this is joint work with Eric Parsons, who's with me at the University of Missouri. And we're looking at using free meal and direct certification data to proxy for student disadvantage with the community eligibility provision now in place, as was alluded to by Dara in her comments. So I think most folks in the room know that we use free meal. I'll use the term free meal to mean free and reduced, or free, I'll use them interchangeably just so I don't stumble over my words as much. But we use free meal data for a lot of things as education researchers and policymakers. For researchers, these are often control variables and models to account for student disadvantage. Policymakers at the local, state, and federal level use free meal data for all kinds of policy implementation and monitoring stuff, all the way up to Title I. I think most of us all agree, although we often don't talk about it, that free meal data have some problems. They're coarse and noisy. So, it's a binary variable, so there's lots of variation in terms of whatever you want to call disadvantage. There's lots of variation on both sides of any cutoff, and then the cutoff, there's people who are on the wrong sides of the cutoff when we go get their income data, and that's been shown. That said, there's some recent research out there by Thad Domina and a big group of colleagues showing that free meal data work pretty well for identifying disadvantaged students. But all of this work that up to now on free meal data has been before the community eligibility provision came into place, and I'll explain that in detail in a minute. But it's a program, for those you don't know, that allows a school or district to identify all kids as eligible for free meals if the school or district is sufficiently disadvantaged, regardless of the individual student's own circumstances. The community eligibility provision, again, alluding to Dara's comments, has created a lot of consternation about whether we can use free meal data the way we've used the data in the past to identify student disadvantage and proxy for these different circumstances that students are in. And then relatedly, direct certification, which is another measure of student disadvantage that I'll talk about in just a second, has been suggested as an alternative, and we're going to do a horse race between the two measures with the community eligibility provision in place. So the community eligibility provision. So two things I want to get through in this slide, just explain what the community eligibility provision is at a very high level, and then explain what direct certification is. They're directly related. Community eligibility provision for a school or district to be eligible for that depends on the direct certification share of students in a school. So direct certification is an appealing measure of student disadvantage, I think largely because it's based on objective criteria, enrollment in an established poverty reduction program like SNAP or TANF. There's the food distribution program on any reservations. Students can also be directly certified if they have particular individual circumstances that indicate disadvantage, like homelessness, migrant status, foster, runaway, these kind of things, okay? And the basics of the community eligibility provision, there's some nuances that aren't really going to be relevant to this work, so I'll skim over them. But the basics is, if your school or district is 40% eligible for direct certification, then everyone can be eligible for free meals through the United States Department of Agriculture, and they reimburse those meals. The reimbursement rate is, there's a scale at 40%. At the minimum threshold for eligibility, you don't get 100% reimbursement. And then I think when you get to 62.5% directly certified students, then you're eligible for this reimbursement. That aspect of the program is not really going to factor into what we're doing, but the bottom line is these schools can enroll, and then what happens in the data, all the kids are coded as free meal eligible, which affects our ability to identify disadvantaged students. Okay, so going through my slides, I was looking at them like I better specify some acronyms here real fast in case you're like me and you space out on a slide or two. If you do that for me and you miss these acronyms, it'll be hard to follow some of the slides. So CEP is Community Eligibility Provision, so that's the program we're going to be evaluating. FRM, Free and Reduced Price Meal Status, and then DC is Direct Certification. Okay, so big picture of the findings that I try and get the main stuff out. The CEP does degrade the informational quality of free meal data, but our interpretation and the results just are the results. You can have your own judgment, but our view is that the effect is pretty modest. I will say from my perspective, it was surprisingly modest. It just didn't do a whole lot of damage. And so some of the concerns about using free meal data, I think we don't need to panic about it. I think it is certainly true. What we're doing now is actually working okay. After finding this result and going back and unpacking everything, there's some pretty intuitive explanations for why the CEP has a modest effect on the quality of free meal data as a proxy for student disadvantage. The two big ones, well, the only two we can think of. The first, right, the two biggest ones. the CEP does induce technical inaccuracies in the data. So it's taking kids at high poverty schools that themselves are not eligible for free meals and coding them for free meals. That's a technical inaccuracy. But the substantive implications of that inaccuracy are not huge. It's not like it's taking a bunch of kids at rich schools and coding them as eligible for free meals. And so it's creating errors, but I would argue the errors are small, and the empirical results bear that out, that it's just not a huge consequence to miscode the kids that are miscoded based on how this program works. The other big thing, which I was not expecting, but it's easy to unpack once you look at the data. To be eligible for the community eligibility provision, you have to have 40% of your kids eligible for direct certification. On average, schools with at least 40% of kids who are directly certified in Missouri, the free meal share is 80%. And so most of the kids at these schools that are CEP eligible, most of the kids are already eligible for free meals. So the number of kids that are changing when this thing hits is just small. And so the scope of the policy is small, and you'll see that. It just doesn't change the status of a lot of kids. So these two things together lead to the community eligibility provision not doing a lot in terms of our ability to use these data. So the first part of the paper is about the effect of the CEP on free meal data. Then we go on to do this horse race. And the horse race would be easier to motivate if the CEP did more damage to the free meal data. But even without that, it's still unclear which measure is better, and there's a lot of reasons to like direct certification data. So we do this horse race and ask, after the CEP is in place, is direct certification a better measure of student disadvantage? And the answer to that question in one word is no. There's a little bit of nuance, but I think the big picture is the measures differ a little in what they capture, but it's not, you can't pick one over the other very convincingly, I don't think. So I think they're pretty similar on net. Again, you can draw your own conclusions. That's our interpretation of the results. And then we do a bunch of other stuff, happy face. I'm not going to have time to talk about all of that. It's all in the paper, but we do some stuff looking at how the community eligibility provision affects value added in models that use that information for schools. We build all kinds of different poverty measures based on the free meal and direct certification data that we use in different ways to sort of come at these summary conclusions. And I'm not going to present all of that stuff in the slides, but it's all in the paper. Okay, so now let me go through what we do and give you a little more detail. So basic, CALDER study. So we're using CALDER data. We have the big Missouri State Administrative Data System that we're leveraging here. We built a 6-year data panel focusing on kids in grades 3 to 8. This is because we're going to use test scores, and that's where we have the test score data. I don't think there's any generalizability issues there, though. So we have lots of schools and lots of students in the data set, and the community eligibility provision was first implemented in Missouri in 2015. And so we built our panels so we have 3 pre-policy years and 3 post-policy years. This is what adoption of the community eligibility provision looks like in Missouri over our data panel. So on the left is counts of schools, on the right is the percentage of schools and percentage of students covered by the CEP. So just on the left, so you can see there's no one adopting the CEP before it was adopted. But in 2015, 231 schools adopted it, and then these are cumulative counts. And so there was slow add-ons after the first year, but most of the action happened the first year. And then we have this in percent terms on the right, just to show that the percent of schools covered is bigger than the percent of students covered. And the reason I'm showing you that is that just shows you that smaller schools on average are the ones that were adopting the CEP in Missouri. This is a product of a lot of the eligible schools in Missouri are rural schools in the state, and they just tend to be smaller. And that's going to play in a little bit of why we get a small scope for effect, but I don't think that's actually the first order reason. Okay. So how are we going to quantify the informational value of free meal and direct certification data? Because that's really what this paper is about. We're going to follow some previous work. There's a number of ways to do this. I like this way. It's been done before, but it's basically taking consequential student outcomes and seeing how well the measure of disadvantage predicts these outcomes. And we're going to say a measure is a better indicator of disadvantage if it's a stronger predictor of gaps in in outcomes that we care about. The outcomes we're looking at are student attendance and math scores test scores in math and English language arts. The math and English language arts test score results are always substantively very similar, so I'm just going to show you math stuff. The attendance results are mostly similar. There's one little difference when we do the horse race between free meal data and direct certification data, so I'll break that out for you. But mostly things are similar, and certainly in the big pictures, they're similar across all of the outcome measures we look at. Okay, So so first, the first part of the paper, which is the first thing we want to do is pin down the effect of the CEP on free meal data, and then go on to do the horse race. And so the framework we have in mind, which I've alluded to in various ways already, but just to restate it, is that the CEP is going to affect the quality of free meal data because it's creating data inaccuracies. So if you can put this in a measurement error framework, it's creating measurement error in that free meal indicator in terms of how well it's capturing student disadvantage. So if you want to think of an extreme example, we could, randomly code a bunch of rich kids in the state as free meal eligible. That's going to create a lot of mistakes in the data. And when we go to look at gaps in test scores between kids who we code as free meal eligible and not, it's not going to show a big gap because there's a bunch of kids we mixed in there who don't belong in there. So the CEP is doing that just at a more directed scale, right? It's miscoding kids who are already at high poverty schools. The prediction is that the nature of measurement error here is quite complicated compared to the simple cases we often like to think about in research. But nonetheless, the prediction is the same, that the CEP should reduce the predictive power of free meal data over student outcomes. And by how much is very unclear, and that motivates the empirical work. So we're going to do a bunch of different comparisons under different CEP conditions in the paper. The most basic of which is we're just going to look in the pre-period before the CEP is placed and the post-period, and we can compare how well free meal data predicts student outcomes. So I think that's a great first step. It's useful to show. It's a little bit hard to figure out what the CEP is doing, though, because other things are changing over time with the introduction of the CEP in the state. Testing instruments, economic conditions, all of this stuff. And so it's hard to back out what the CEP is actually doing. So our strategy for isolating the effect of the CEP is what we're calling these pseudo-coding scenarios that we've created in our data set, where we're basically going to falsely code schools as adopting the CEP before they actually adopt it. And this strategy is going to allow us to hold everything else about the data as the same, and we're just going to go falsely code some schools as if they had adopted the CEP before it happened. So I'll illustrate the idea with we have 3 different pseudo-coded scenarios that increase the prevalence of the CEP. So I'm going to go through this with the most basic, which is the lowest prevalence example. So what we do is in 2015, you saw those 231 schools adopted the CEP. And so what we do is we go back in the data before 2015, and we code them as if they had adopted the CEP before they actually adopt it. And then we can run our models, and we can predict, we can estimate how big is the effect of the free meal indicator, the big free meal test score gap, I should say. How big is that gap with the CEP coding in place? And then we can just undo that pseudo coding and compare it to the real data, and that allows us to see what the CEP did, okay? And so then the second scenario, we're gonna increase the prevalence of the program a little bit by including any school that ever adopted the CEP in our data panel. And then the third case, which I've bolded because I think it's the most interesting case, given my interpretation of our findings, they're pretty modest, we can go in and we have the direct certification data. And so we can go in and figure out all the schools that would be eligible and say, look, suppose every eligible school adopted the CEP. Then what would happen to the quality of this information? So we can get this upper bound effect of the program based on its rules. Okay, so I'll get to so I'm going to get to the findings. The first thing I want to do is just lay the groundwork for the scope of effect of the CEP, and I'm sort of reducing information in the slides so we can not get overwhelmed. But I've got 3 of the different conditions we consider shown here. So there's 5 total conditions. There's the actual pre-period data and the actual post-period data, and then these 3 pseudo-coded conditions. And I'm just sort of skipping some of the middle stuff where the inference isn't as useful. So in the pre-CEP period in Missouri, no one adopted the CEP, and 51.2% of kids were free meal eligible in the data set, okay? If we go take those schools that adopted in 2015 and we go back in time and act like they had already adopted the CEP and overwrite their students' free meal data, 13.2% of schools did that, but the change in the number of kids eligible for free meals in the state is like nothing, 1.7 percentage points. And so this is going to foreshadow our small effects of this policy on the data, because just not the status of most kids just doesn't change, okay? And then the last pseudo-coding scenario there on the right, that's when we code every potentially eligible school as if they had adopted. About 30% of Missouri schools are eligible, so we can put all those schools in and say they all adopted the CEP, override all of their data in the pre-period. Now what happens to the share of free meal eligible kids in the state? It only goes up by 5.3 percentage points. I mean, 5.3 percentage points isn't nothing. I don't want to totally dismiss that, but it's also not a huge number. And if you think about the overall ability of these data to predict outcome gaps, it's just not a huge effect. Okay, so then I'm going to go on and show you the achievement gap results, and I'm going to show you two comparisons under the different CEP conditions, the real data ones and the pseudo-coded ones. I'm going to give you two estimated achievement gaps. One is the simple one is just between students who are coded as free meal eligible and not. Ignore anything else. So just think of that as on average in the state, what's the test score gap between kids who are and are not coded as free meal eligible with different coding rules based on the CEP. And then I'm going to add this measure of local disadvantaged or school disadvantage, and Dara also alluded to this being an issue of predictive measure. So we're going to compare students who differ by their own coded eligibility for free meal status, and also by the share of kids in their school who differ by free meal status, and we're going to generate a 50 percentage point gap in the share of kids eligible to school. So that's about 2 standard deviations of the distribution, or going from 25% of the kids at your school being eligible to 75% of the kids. And we're going to compare the test score gaps predicted by the models under the different data conditions for these two students as well. Okay, just to clarify what we're looking for here, if the CEP has no effect at all on the quality of data, the comparison the gaps that we predict in achievement should be the same under all the different CEP conditions, right? If the CEP is changing the quality of data, the gap should start shrinking as the CEP bears down on the data. Okay, so this is that first comparison. This is just statewide. This is standardized test scores. So this is the average difference in test scores between free meal and non-free meal eligible kids in Missouri under the different pseudocoding conditions. I've got all the scenarios up there. The blue bars are where I want you to focus your attention. On the left there, the pre-CEP period, that's before the CEP was in place. It's minus 0.62 is what that bar is showing if you can't see the axis there in the back. But basically, so on average, free meal eligible kids in Missouri scored 0.62 standard deviations lower on the test than non-eligible students before the CEP was in place. In the maximum upper bound condition, where we use those same exact data and we just overwrite all the kids in CEP schools as being free meal eligible, the gap, if you squint, you can see it shrinks. It goes to 0.61, but that's nothing. I mean, it does nothing, I would say is a fair interpretation of this result. So for the individual measures of student disadvantage based on free meal data, the CEP has no effect on the quality of the data, which I think speaks to both of those issues I mentioned earlier about the technical inaccuracies not being that big of a deal, and there are just not that many kids whose status changes. We do see a little bit when we incorporate the school average free meal variable, so trying to get the contextual poverty information. So this is where we compare kids who differ by their own status and 50 percentage points in the share of kids in their school who are free meal eligible. And we do see a gradient now. So now you can see as the CEP has more bite, the gap gets smaller. This is the same exact data, same exact kids. So this is really just indicating the degradation of data quality here on these variables. So, it's kind of in the eye of the beholder how big this gap is. It's a pretty big effect size in terms of moving in the distribution of the share of kids eligible for free meals. But in the upper bound condition, you've got about a 0.15 difference in the achievement gap predicted between these two students, driven by the difference in the school average share. So big picture interpretation, my first order interpretation is the results are modest. The more nuanced version, in terms of individual measures of student disadvantage, the CEP doesn't do anything. In terms of school level measures, it does do something. And that's where the action is. So in the paper, I think knowing this is actually very helpful for thinking about what to do about this, if you want to do something about this. And so in the paper, we talk a little bit about how researchers and policymakers might react to the CEP, given that this is where the problem is that it creates. And there's some fairly basic things to do, like pulling in data from other sources and things like that. Okay, so then we go on to the second part of the paper to compare free meal and direct certification data. So now we're going to shift entirely to the post-CEP period. The CEP is in place. We have this 3-year data panel, and we're going to see which type of measure predicts gaps in student achievement better, free meal or direct certification data. Direct certification, now I'm realizing there's some good citations actually for some of this conversation out there that are not on my slides recently about using direct certification data. This is a commonly advocated solution to this CEP problem, if you will, that we should shift to using direct certification data. So we're just gonna horse race that and see what happens. let's see here. Yeah, so we're going to use the same fundamental approach, comparing outcome gaps created by the outcome gaps for the different types of measures of disadvantage. We have a bunch of different measures of student disadvantage that we create for the free meal and direct certification data. I'm not going to break all of that down just because I don't have time. I'm just going to give you the most basic comparison, but I think it gives you the right flavor of our findings, and you can unpack it deeper in the paper if you're interested, or we can talk in Q&A or offline. Okay, so this is after the CEP is in place. These are achievement gaps between students who differ either by their free meal eligibility or direct certification eligibility, just as coded in the real data after the CEP is in place. If we thought direct certification was a better indicator of disadvantage, we'd expect that grayish bar there to go deeper, right, to indicate a bigger gap. But in fact, it's the reverse. I mean, I would argue these results are actually pretty similar. But what this is telling you is that direct certification and free meal data, the gaps they create in student disadvantage are quite similar. And I would say neither measure is clearly preferred. And if you had to pick one, I think you'd pick free meal data as a better proxy for student disadvantage, even with the CEP in place, based on test scores. And that holds over a number when we add a bunch of different dimensions of variables and ways of measuring student disadvantage, including the aggregate measures where the CEP does do some damage. It still doesn't do enough damage to make the free meal data meaningfully worse. The one place where attendance data show a little bit, so this is for math achievement, reading achievement, you see the same thing. In attendance, I'm just gonna flip real quickly. The main thing I want you to see with attendance, DC data indicate bigger gaps in attendance. And so the gray bar and black bar, their relative size flips when I switch the outcome between achievement and attendance. Again, the differences in magnitudes are not that big. So this is where I get to the summary conclusion that direct certification and free meal data are pretty similar in capturing disadvantage across the different measures we have. Okay, so just really quickly, I don't want to say everything I've already said, but the first part of the paper about the effect of the CEP on free meal data, I think the main takeaway for us is we shouldn't panic, right? I think what we have right now can probably be improved on. We should always be trying to improve, but if you liked free meal data 5 years ago, you probably shouldn't start hating free meal data right now. Things just haven't changed that much. And so if we want to make progress toward better measures of disadvantage, I think there's ways to do that, but we don't need to panic or freak out or anything about what we have now, because it still seems to be working pretty well. And I think there's some value in knowing exactly where it isn't working, which is in that aggregate measure. DC and free meal data are similarly informative about student disadvantage. And there's a little bit of difference in the types of outcomes we use, but big picture across a lot of different ways of looking at it, I think that holds. And then something I won't elaborate on too much here, but I do think it's pretty, I think our findings should generalize pretty comfortably to a lot of settings, at least if there's similar eligibility rates for the community eligibility provision and similar take-up rates. And those are very easy numbers for states to calculate. And so I think states can get a very quick sense of how well these findings will generalize just based on that. If you're in a state with a much higher prevalence of the CEP, either in eligibility or take-up rates, then the results may be less likely to generalize. But I think we've laid out a pretty basic infrastructure for trying to figure out how important this would be for different states. So that's it. Thanks.